Uh, Today we will solve the problem 4.24 of Griffith third edition Introduction to Quantum Mechanics. This problem consists of two parts. Part A is derive the equation 4.31 from the equation 4.13. So here the equation 4.130 is that we have to derive from this. That is L plus or minus is equal to plus or minus h cross e power plus or minus I pi multiplied by delta over delta t plus or minus I cot theta delta over delta pi. And from this we have to derive the equation 4.31 as problem given. That is L plus and L minus plus L minus is equal to minus h cross squared delta 2 over delta t2 plus cos theta delta over delta t plus cot squared theta delta 2 over delta pi 2 plus I delta over delta pi. Now we can separate this, that is L plus from equation 1.30, L sub plus, that is rising operator is equal to, we are taking only the upper sign part this. So plus h cross E plus I pi multiplied by delta over delta t plus I cot theta delta over delta pi. Similarly, the lowering operator L minus is equal to minus h cross e power minus I pi multiplied by delta over delta t minus I cot theta delta over delta pi. Let us take that rising and lowering operator act on some arbitrary function f. Remember that in quantum mechanics you are not supposed to change the order of the operator. That is, the lowering operator act on f first, then rising operator. So as given in the problem, this rising operator is the first square bracket, terms given in first square bracket, and the lowering operator is the terms given in second square bracket. So now this f will lowering operator act on this f. So naturally you can bring this f inside the lowering operator. That is, I am bringing this inside. So this, there are only two differential operator with respect to theta and with respect to phi. I brought this f here. Now another thing is, I am going to take this plus h cross and minus h cross, these two term outside. So which will become, if you multiply, you will get minus h cross square, and the exponential term comes first. There is no operator before this exponential term. So you can take that also as it is. So that is e power plus I pi. Then the remaining term is delta t over delta theta plus I cot theta delta over delta pi. Then here you have e power minus I pi delta f over delta theta minus I cot theta delta f over delta pi. This you cannot take outside because there is a differential operator with respect to phi is sitting here. Then now you differentiate this with this. You take the first differential operator in the first square bracket and differentiate this. So the first term is e power minus I pi. There is no theta dependence. You keep as it is. Then differentiate delta f over delta t, which will become delta 2 f over delta 2, delta theta 2. Then you differentiate the second term. That is this second term. Here the second term is this exponential minus I cot theta. So you can keep minus I here. The second term is minus I this exponential e power minus I pi, then cot theta. I am keeping cot theta as it is. I am differentiating the second term delta f over delta pi, which will become delta 2 f over delta pi and this delta theta. So next what I am going to do is I am going to keep this e power I and this I as it is, I e power minus I pi. So here you have one I and e power minus I pi. And if you differentiate this cos theta, differentiate this cot theta, not cos theta. If you differentiate this cot theta, you will get secant squared minus secant squared theta. So here minus of already there is one minus. Minus of minus will become plus. So this is plus. You have I here and e power minus I pi here and uh, uh, cosecant square theta. Sorry, cot theta, if you differentiate, you will get minus cosecant square theta. So you can write cosecant square theta. Then you have this e power minus I pi, and of course you are keeping delta f and over delta pi as it is. You are differentiating only cot theta, which will become minus uh, cosine theta. Cosine theta square minus, of course, 90 sign. Minus of minus will become plus. Here we can eliminate some of the, particularly the exponential term. You bring this exponential term inside the bracket. This is plus I pi, this is minus I pi, which will become 1. Similarly, for here, you will get, sorry, you leave I as it is. So this will become 1 if you multiply this, and also here it will become 1, and here this will get cancelled with this e power plus pi. Similarly here. So you can rewrite the this expression without the exponential term. We will see now. After cancelling the exponential term, we got this expression. Here you can carefully analyze and cancel some of the term. You can see here minus I cot theta delta 2 f over delta pi delta theta. Here you can see this term. Of course, you have to multiply this by I cot theta. So if you compare these two, this is both are equal and opposite in opposite in direction. That is, this is minus, this is plus. Plus I cot theta delta plus I cot theta delta 2 f over delta pi delta theta. So this term and this term will get cancelled. Then you rewrite the remaining term. So you have minus h cross squared. The first term is delta 2 f over delta theta 2. Then plus you have I cosecant squared theta delta f over delta pi. Then next you have I cot theta. Then you have I. If you multiply this by I, you will get first term minus I delta f over delta theta. The second term will become minus of minus will become plus, and I squared is minus 1. So this will become minus cos theta tf delta f over delta pi. Then the last term is minus I cot theta delta 2f over delta pi 2. So now you bring this cot theta inside. You keep first two term as it is. Then you multiply this. If you multiply the first term, you will get I into I squared minus 1, minus of minus will become plus. So the first term will become plus cos theta delta f over delta theta. What about the next one? There is already cot theta. So this will become I cot square theta delta f over delta pi. Then here I cot theta, here I cot theta, minus I cot theta, which will become plus cot cot squared theta delta squared f over delta pi 2. So we will reduce it further. So we got this expression finally. Here you can take this term I cosecant squared theta delta f over delta pi. Here minus I cot squared theta delta f over delta pi. You combine both. You will get you can take I outside. Then is cosecant squared theta minus cot squared theta delta f over delta pi. So remaining thing I am keeping as it is. Here the cosecant squared theta minus cot squared theta is 1 using trigonometry relation. Then this will become first term is and also you cancel this f everywhere f f here also f. So you will get minus h cross squared delta 2 over delta theta 2 and here it is 1. So I can take this at end last, that is I delta over delta pi. This will become I. You have I here. I delta over delta pi. Then this term is cot theta delta over delta theta. And next term is cot squared theta delta squared delta 2 over delta pi 2. So which is exactly equal to equation 4.31. That is we have started with the equation 1.30 and end up with 4.131. So hence this answer. Now we will move on to section P. Next section P is derive the equation 4.132 from equation 1.29 and 4.131. They have given hint also, that is use the equation 4.112. That is we have to derive this equation 4.31, third one, 32 I mean 4.32 using the equation 4.2 4.129, that is LZ. By definition it is equal to, we know very well, it's equal to minus I h cross delta over delta pi. And in section A we have seen L plus L minus is equal to in this problem itself we have seen in section A L plus L minus is equal to minus h cross squared delta 2 over delta theta 2 plus cos theta delta over delta theta plus cot squared theta delta 2 over delta pi 2 plus I delta over delta pi. That is equation 4.13 which we have proved in section A. And L square, we have to prove this. L square is equal to minus h cross squared 1 over sine theta delta over delta theta sine theta delta over delta theta 1 over sine squared theta plus 1 over sine squared theta delta 2 over delta pi 2. We have to prove this using these two equations. And hint is L squared is equal to L plus or minus L plus or minus multiplied by L minus or plus plus L z square minus or plus h cross Lz, that is equation 4.112. So we have to prove 4.132 using these two equation and applying this hint. We know by definition Lz is equal to I minus I h cross delta over delta pi, and we have seen this expression also. L squared is equal to L plus or minus into L minus or plus plus Lz square minus or plus h cross Lz. Now from section A we have seen L plus multiplied by L minus. L plus L minus is equal to minus h cross square delta 2 over delta theta 2 plus cos theta delta over delta theta plus cot square theta delta 2 over delta pi 2 plus I delta over delta pi. And here you take upper side, L square is equal to L plus L minus plus Lz square. Here we are taking upper sign also, minus H cross Lz. So we know this first term, L plus L minus, this term you take as it is here. Then what is plus Lz square? If you take Lz square, if you take the square of this one, you will get to minus h cross square delta 2 over delta pi 2. Then what is minus h cross Lz? If you multiply this with minus I h cross, here you have minus, here also you have minus. This will become plus I h cross. Already there is another h cross here. So this will become I h cross square multiplied by delta over delta pi. Now we will try to simplify this. So finally we got this expression. Now compare the terms. You take minus h cross square and multiply this, which is equal to minus I h cross squared delta over delta pi. Here you have plus I h cross squared delta over delta pi. So this will get cancelled with this term, because we are multiplying this by minus h cross square. So this will become minus I h cross square delta over delta pi. This is plus I h cross square delta over delta pi. So this and this will get cancelled. Now we got this one. Only this term left here. This cancelled. After rewriting this, we got this. Now you can take minus h cross squared as a common, because here you have minus h cross squared. You bring delta 2 over delta pi 2. So if you bring inside, this will and combine this and this, you will get cot square theta plus 1 delta 2 over delta pi 2. We know very well that cot square theta plus 1 is equal to cosecant square theta. And the remaining term I am keeping as it is. So this will become minus h cross square delta 2 over delta theta 2 plus cos theta delta over delta theta 2, sorry, delta theta, and this is cosecant square theta delta 2 over delta pi 2. Now we got this expression. Here what I am going to do is cosecant square theta can be written as 1 over sine square theta. Now if you combine these two parameter, you will get these two. So we can prove this easily. Let us take 1 over sine theta uh, delta over delta theta sine theta delta over delta theta. Now you keep sine theta as it is and differentiate the next one. So what will happen? Then you have sine theta. I am keeping sine theta as it is. Here you have one sine theta term in the denominator. Then this will become delta 2 over delta 2 over delta theta 2. So if you keep this as it is and differentiate the second term, so this will get cancelled. So you will get this term. Then next what you are going to do is you keep 1 over sine theta as it is, 1 over sine theta. Then you differentiate this sine theta, then you will get cos theta. Cos theta t over t theta. So if you divide cos theta by sin theta, you will get cot theta t by t theta. So this second term. Now you can understand both the equation are equal. So if you expand this, you will get the first two term. So we have proved the equation 4.32. Subscribe to my channel to get my latest videos, and join my channel to support its growth and enjoy the exclusive perks. Also use the thanks button to make one-time contribution and support my channel. Thank you very much.